Hi, here we go on our next lab, trying to build up to our balloon challenge. I'm going to briefly talk about Jacques Charles, a scientist who was known for his work with gases. He also made a lot of contributions to the sport of ballooning. He was one of the first people in 1783 to use a hydrogen balloon to rise into the air. It didn't carry any people, but it rose 3,000 feet. He also did a lot of design improvements. He was elected to the French Academy of the Sciences in 1785. Kind of an important older scientist. Has a lot to do with what we are going to be talking about today. Now, I get that these are going to be some higher concepts. We will talk about them at length when we're done, try and generate some examples that we can think about, but let's start with how pressure and temperature of a gas are related. Now, you'll see throughout this, pressure, temperature, and volume are all related, and they're all related in different ways, right? So when we start talking about two in relation to each other, that other one is assumed to be the same. For instance, when we're talking about pressure and temperature, when we start talking about it, we're going to assume that though we're changing either the pressure or the temperature, the volume, we're going to keep the same. So remember, we've been talking about this last probably 2-3 days. Temperature is energy, right? So the higher the temperature of something, the more energy its particles have, the faster they're moving. The faster they're moving, the harder they're hitting each other, the harder they're bumping into the walls of the container, causing, pressure to happen. So when we increase that temperature and we add more energy, the pressure of that gas also rises, right? We get more and more pressure. When we decrease the temperature of that gas, the pressure also decreases. It falls, right? So this is why sometimes you see truck tires explode, right? You've increased the pressure by increasing the temperature, and eventually the wall of the truck tire fails and it explodes because, the road's hot, the sun's hot, the tire gets hotter and hotter and increases the pressure to the point that the tire can't take it anymore. The second concept we have, we're going to talk about how volume and temperature are related. So volume is directly related, directly proportional to temperature. When you heat a gas and you don't let the pressure change, it's going to take up more space. Its volume is going to increase. When you cool a gas, it's going to take up less space. Its volume is going to decrease, mostly because you're taking energy out, and that the molecules don't have enough force to bounce and take up the same amount of space that they were taking up before. This is called Charles' Law, because this is why I talked about Jacques Charles, the very first slide, because he was going to come up again, right? He discovered this. So, temperature and volume. When we heat a gas, increase the temperature, the volume increases. When we cool a gas, the volume decreases. Last but not least, and this is the one I kind of have the most difficulty with, when we don't let the temperature of a gas change and we add more pressure, we decrease the volume. What does that mean? We can smash a gas, right? When you push on the gas, you can make it take up less space. The same is true when you let the gas have more space, it will expand to fill that space, right? So when we decrease the pressure, the volume increases. When we increase the pressure, the volume decreases. Think of it like this way. You can smash a gas, right? Now, this is called Boyles Law. This tells you that pressure and volume are inversely proportional to each other. Inverse just means when one goes down, the other goes up. When one goes up, the other goes down. This gives us a very big, complicated formula that I'm about to show you. So, hold on.